Welcome to lesson 5 of chapter 8, Advanced Enum. This lesson, you will learn how to create a complex enum structure by learning about a recursive enum. Some may not have heard about the term recursive before. That's okay. I'm going to walk you through by learning about a recursive function. Nonetheless, this lesson can be challenging. Let's begin. Welcome to Learn Swift with Bob. In this lesson, we'll talk about recursive enum. Well, this is more like a data structure, learning about what Swift offers when it comes to enums. So the problem statement here, enum contains its own enum type. Well, I'm not going to go straight into recursive enum for now, but let's have a brief overview of what recursive function is so you understand what recursive means when it comes to programming. So when you have a function called recursive function, of course, this is not recursive yet, but you can call a function like that. But what's happening is you can actually have a function within a function. So what's happening is you're calling a function, and then it calls that function, say hi, and then goes back, calls it again, calls it. It's like kind of going through a loop. So recursive means kind of going through a loop or happening many times. So when you now call recursive function, when you call it here, it's gonna have a lot of it's going to repeat forever. It will never stop. So what's happening is you could call it, it hits this part, say hi, and then go back here, say hi, go back. It's kind of repeating yourself again over and over. That's what it means to have to use something recursive, using its own type or using its own function over and over and over. Okay? So now you understand what it means to use a recursive function. So now let's talk about recursive enum. We're going to learn how to apply recursive enum to work with how to do multiplication, how to do addition with the associate type within enums. Well, it may not really make sense right now, and a lot of people will freak out and may not understand exactly what's happening. But again, it's a tough concept, and you might face a little bit of problem. It's okay. You can comment below. You can always ask me out if you ever get stuck. So we're going to create an arithmetic expression. Let's say this is an example from the Swift documentation. I like their example, so I'm going to use it. And let's say we have 3 cases. Okay, we have 3 cases available. We have one. They're both associate type. Okay, so we have a number. When you initialize, you gotta enter int. Okay, but when you have an addition, we're gonna create a function later down the road working with this object later. But when you create this object, you have to enter arithmetic expression, also just its own type. So again, going back here, enum contains its own type. You're not allowed to do that. Well, it does. Anyway, I'm just gonna keep talking and then come back to this. Well, you have addition has 2 type. You have to enter, which is arithmetic expression its own type, and the multiplication number 1 is number 2. Okay, but here's the problem. The recursive enum is now marked as indirect here, so you have to use the word indirect in this case. This has to do with reference type and valid type. Well, I haven't talked about valid type within enums. We're going to talk about in chapter 10. So if you want to, for now, just assume that if you have your own enum type here, you have to use indirect for now, and then we'll talk about more in chapter 10 what it means to be valid types when it comes to enums. So for now, indirect. If you want to work its own type, you got to use indirect. Okay, so just follow me along. I'm gonna walk you through very slowly. Okay, so now you can create a couple object. Now you can create an arithmetic expression .number, and you can enter 4 here. So you have number 4 on the right side, and let's create another object. Arithmetic expression addition, and here you can enter number, right? You can enter number 4 or 5 or number 10. It doesn't really matter, because now what's happening is arithmetic expression has what is a type. It contains 3 types. One is case, okay, number. It contains number case, also contains its own addition case and multiplication case. So for me, in this case, I just enter number 5 here, which is the case of number 1, and enter 5 in this case. Okay, you're able to you can let Swift infer. For those who are a little confused, what I'm doing is this way. I'm just omitting the arithmetic expression enum, because Swift can infer. It can pick and choose. Okay, so now you can also have 4 or 5, right? Just done it before. Let 5 and 4. But here's the thing. So what are we gonna do about this part? So now what we're gonna do is we're gonna create a function, okay? What the function does is you're gonna enter this arithmetic expression enum object into the function, and then you're gonna do some sort of a manipulation with that. So just copy paste this because it may overwhelm you, but I think it's better to just copy and paste, explain it one by one. Okay, so here we go. So now what's happening is you have a function called evaluate, okay, and then here we're gonna enter this enum type. Enum, it could be there are 3 cases you can have. You can have number, you could be addition with this arithmetic expression, or you can multiplication, right? And then it's gonna return int in the end. Okay, cool. So let's say we have enter, for example, evaluate. Let's say we enter number and 5. Okay, so you're gonna go through number 5 gets evaluated in the expression here, and if there are 3 cases you can have, which is number case, addition case, multiplication case. In this case, what's happening? You're entering what? The number case right here, right? You're entering number case. So case let number, you take the value, which is 4, and simply returns the value of 4. That's why you see on the right side, it gets 4. Okay, but that's the most simple aspect where there's nothing recursive going on here. But what happens if you enter evaluate and then you have a multiplication, you have a number? I know it gets a little complicated. Let's say what happens when you enter, for example, like this way, evaluate, let's call it addition enum right there, and then you're going to enter evaluate and enter addition enum, okay, right there. Again, you're able to do that because if you take a look at it, expression takes arithmetic expression, right? And this is addition enum is also arithmetic expression. It's nothing more than having this the second case right here, but also it contains its own type. Are you guys following me along? So now when you enter addition enum here, in this case it goes through evaluate here, switch statement, but in this case it's right now the second one right there. The case is second case, which is addition, okay? But now here's the thing. Here's the trick. So on the left side is what? Is actually arithmetic type again. On the right side is arithmetic type again, right? This is the first case. This is the first case as well. So you take the first case, which is left, or the enum case of 5, and the right is enum case of 10, and then you do return evaluate left, which is we evaluate left. So you're using this function again, and then in this case you are entering this arithmetic case number 1 into an expression here. It goes through it, and probably in this case you get number, this one. This becomes a case. So it returns what? It returns 5, and when you do number 10, it returns 10, because evaluate again, you use this case, and then it goes through that evaluate function again, and it hits this first case and returns the pure number of it, so 5 and 10. So now it gets 5, it gets 10, and later you get 15 on the right side. Okay, am I making sense? You might have to think a little bit if you're not understanding this part. When I first saw this enum, recursive enum, I thought, wow, this is a little tough, right? For me, I'd never done recursive programming before. Back then, it was tough. So if you are having a hard time, I recommend you guys just keep looking at it, staring at it, whatever you can. You can ask me questions, but hopefully you guys can understand what I'm talking about. Again, let's do with multiplication now. So multiplication is it's the same thing here. So we have let's call it multiplication enum, right? Arithmetics expression multiplication. You're gonna enter 5. Let's do 10 and 10, and then we have a number 10. So hopefully it returns 100 later down the road. So now let's try to do this. Evaluate. Okay, you're gonna enter what was it called? Multiplication enum right there. Boom. So now let's see what's happening. So when you call this evaluate, this is a case 3, the third case, which is multiplication, right? And it contains a left and right side, which is number 10 and number 10, number 10 and number 10. But this is actually case 1. So you're gonna call this evaluate. You're gonna evaluate the first case. So eventually it goes through the evaluate again. All right, enters the case 10, case number 1 with 10 value of 10, it returns 10, and evaluate returns 10. Okay, that's why 10 times 10 becomes 100. So it's gonna go through like multiple, it's like a recursive, going on and on until you get the very last value, until you get to the case let of this case. Okay. So that's what's happening with recursive enum. In this lesson, my focus is not to just make you. This lesson was not learning how recursive enum can be practical, but more like what enum can allow you to do, and then also learning about what recursive function enums are like. Okay. Yeah, that's it. But for me, when it comes to, again, learning about enum is useful, but also is not the most optimal way for you to solve every single problem. There's people say, we talked about in the last chapter, learning that protocol, there's a problem with that, and enum, there's a problem with that, right? Like this, we don't want to do simple multiplication and addition with this kind of method. This is very complex, right? So as a programmer, as a developer, you've got to know all. So what I wanted to show you in this lesson was that there's no such thing called we call the silver bullet, or the ultimate thing that allows you to do everything. In programming, there's no such thing. There's always pros and cons. So let's talk about how I would approach what I would do when it comes to adding a multiplication when it comes to programming. Well, let's begin with the normal enum Alternative, so we're starting with the enum just like that, but we have two cases, addition and multiplication, okay? And then we're gonna have a result property on the bottom here, switch self, okay? If it's addition, multiplication, case let addition, get the first number, second number, return number 1, number 2. You should be very familiar with this syntax right now. If you're not comfortable with syntax of this, I recommend you guys go back and learn more about enums. Okay, that's one way you can solve this problem. There are many ways to solve this problem. You can use recursive enum, but you may come across more smarter, but it may not really necessarily provide better communication between your teammates, which is the ultimate goal when it comes to coding. You always code from the perspective of somebody else, not just for yourself. So you can code like this: operation addition 4.4.result. You can do that. But this is good enough, but I don't like the fact that we have to use the word this result property. So I don't like, what I want is actually, just when you call this method, I just want it to return the number 8 right away. So I don't want to call result. So this may not be the ultimate, the best way to go about. Well, we can do another alternative by making a class. Okay, so we have struct operation. We have an add two numbers. You're gonna enter number 1, number 2, returns int and number 1 and 2. Multiply numbers, number 1 and number 2, and number, you get the point. So all I have to do is struct operation, add two numbers, and 4 and 9. But I don't like the fact that we have to create this object. This is a little ugly. So what I would do in the end is actually just using closure block, just like that. I call it math operation, okay, and then call addition. Just enter the first parameter, second parameter, and then this is a closure block. How pretty is this? Nobody has to create this number 1, number 2 imperative code. This is more like functional way to go about. You know what I'm talking about? We learned in chapter 5, right? Chapter 3 and chapter 5. This is how I go about if I have to organize my code. So all I have to do is boom, right there, it returns 20. So now we've taken a look at many ways to solve a single problem when it comes to coding. So when somebody said like this is the ultimate way to go about, this is the best way to go about, you need to be really cautious about what the person's talking about. There's no such thing as one way that fits all. So don't ever trust someone that says this is the best way to go about. No, there's always pros and cons. When you take choose this path, there's something that's missing, but that's also good stuff out there. When you choose this path, there's something good, but also missing. So which one has the least amount of missing stuff? And then you pick and choose. So that's why learning about the fundamentals is such an important topic in this course, because a lot of people, what happens is they simply try to pick one spot and then go with that route and not learning about anything else that exists out there because they think they're not important. But it just allows you to take a look at, okay, what's missing? What do I need now? Let's use that method. I know that there's some downside, but it's better than using the other. So that's why I made this course. It's not just about making apps, okay? For me, if I were to make an app, just it'd still be hard, but because I know pretty much everything about Swift when it comes to using syntax, not the internal part, such as compiler, I can make any apps if I wanted to. They're all about closure, learning about the fundamental rule, which is talked about in chapter 1, lesson 1. So I hope you guys don't complain. I think no one's complained the fact that you're learning all this feature. You might be thinking, why do I even learn about recursive enum? Well, it may not be that important right now, but it's important to understand why we do use this method, the bottom method. Why do we use this method instead of using the method above? That was a little bit of my rant, because some people complain the fact that I need to keep making practice problems. Practice problems are like the worst in my opinion. Here's why. Because when you are, for me, when I learn about web development, server development, building email service, it's not like there were practice problem for that. Nobody has designed a practice problem for building a server, but more like, what do you know about programming? What tools can you use, and how to put everything together into one basket or piece. Practice problems, oftentimes what happens is they kind of give you the answer up front, and it's invisible. The answer is invisible, but they kind of like, hey, try to solve this invisible problem, but it doesn't really work that way in real life situation. There's no like invisible problem solution out there. There's no solution. So for me, I don't like practice problems. I always talk about the fundamentals. So if I were to learn about Android development, if I were to learn about server development, it all comes down to fundamentals: static method, object-oriented programming, functional programming, protocol programming. So just learn those fundamentals, please, before you move on to the next step. So now you'll really appreciate what I'm going to offer more and more throughout the course. So there was a little bit of a rant. If you, just keep learning, and if you have questions, comment down below. You will appreciate what I'm gonna offer in the next course, because you will learn how all these things fit together in a real life situation. Doesn't really matter if you're coding in iOS development, Android. The platform doesn't matter. It's all about getting the fundamentals of programming, which we are doing right now, and you're becoming a better developer with me. See you. One of code smell is called needless complexity. Please remember that protocols and enums are double-edged sword. If you don't know how to handle them very well, it may hurt you. Chapter 10, you will learn more about the meaning of indirect by learning about binary tree data structure. In the next lesson, you will learn how to combine enums with generics. Let's begin the next lesson.